Hello. DraftPhysics has made a reply to my video about the nature of light, whether it's wave or particle. I always appreciate people looking at my work and asking questions. And I think Gary has asked a number of good questions. I think he's a good guy, and I think he deserves a reply on each of these points because he's right. It's not a debate if people don't have a discussion. So let's get into it. So I've got his main screenshot over there about the main points. I would agree, first of all, Gary, yes, light is a ray, okay? I think that was one of the main realizations that I came to, that as far as figuring out what exactly light is that it's like a ray. It's like this pen. So it's longer than it is, say, skinny. It points in a particular direction. It occupies a finite amount of volume and space, right? So this is what we mean by a ray. Okay. So now the question is, you asked a perfectly reasonable question, is, well, how can this be a wave, right? Sounds absurd. Okay, and now in certain ways it does. So let's address each of your points here. So first you show that waves, they disperse, right? And they do. And this is in ordinary mediums, particularly, say, water, right? Or air. We know that this is one of the main physical characteristics of waves, is that they disperse. So, the ray couldn't possibly stay in one piece if that were the case, right? Okay, but the way that I solved that problem is by showing that, well, it there are some examples of particulate uh, phenomenon. So if you've seen the vortex cannon kind of thing, it's this rubber, like a bucket with a rubber membrane in the back. When you flip it back and you flick it, it like sends this very concentrated vortex through the air, and it doesn't disperse. Now, I personally feel that isn't what light does, but I just want to give you some physical example to show that it is possible in ordinary, dispersive mediums to have a non-dispersive phenomenon. Okay, so that's one way you can think of, how is it that the wave can stay in a ray-like, you know arrangement, in that there are some things that can hold together even in particulate matter. But I think that you're right that I am a an ether guy, and I think that the reason why I like to stick with that idea is because I want to have a fully mechanical universe that doesn't invoke any magic or things that we don't particularly know exist. So, as my main objection to, say, the purely particle um, view of the photon is that, well, we have not actually found it. So, if you could show me an experiment where you could say that this is just like the electron, right? It's like a little ball, and we can definitely kind of see it, and this is what we call it, right? But it doesn't seem to be like that. It seems like the photon is literally a packet of energy, right? And for me, packets of energy are more readily transmitted through particulate mediums as a wave. And another part of the motivation that I have for why is it this thing can hold together is that the medium of space, which I believe is a positron electron, basically a neutron C, is that it actually does have a special place in the universe, in that it is a frictionless superfluid. So basically, the concept of friction, which is what everything else encounters, in the world, like the atmosphere and the air and the water and the waves, they experience the concept of friction because particles collide into each other and they collide in opposite directions. And because of that, they're always going to be losing energy and changing direction. But because the ether serves as the foundation, as the basement for all movement, that technically they can't actually crash into each other in the opposite ways and can't lose energy in different directions. Now I know that's a little bit hard to accept, but there are things we do know about, like superfluids and superconductors, that you wouldn't think would be possible, if just looking at ordinary particulate mediums like water and air, right? You wouldn't think that a current could like go around forever with no losses. It's got to be hitting the atoms, but yet it does. And you have things like superfluids, which flow with liquid helium, which flow with absolutely no viscosity, and probably liquid helium would probably be about the closest stand-in as we have for what I think the ether actually is. Okay, so so I give you a couple motivating factors. It's like, yeah, it's a ray. It looks like my pen, and it works because everything that it goes through goes in one straight direction, similar to, say, the vortex cannon. So the waves, I suppose you could think of it's just like in a circular thing, and it's just a boom, and it is just going through the ether in this very, very compacted way. So the other thing that I wanted to bring up in particular is the motivation for how and why the light gets created here. Okay, so now typically we have the idea that we have the atom here, and what happens is that the atom gets excited, and we have electrons here, and what they do is they go, they jump up and they go down, and when they do so, they emit a light wave. Okay. Now, we do know that this process is quantized in that it can't emit just any frequency of light. They seem to be limited by specific quanta. Okay, so like hydrogen, it will only produce a line here, a line there. Only very specific frequencies will come out, and the reason why is because the space itself is quantized. Okay. Now you mentioned in your drawing over there that if space is quantized like this, that the electron is not going to be able to like move in anywhere, and that's actually an important concept in the creation of light, because that means that an electron can only go, say, integer distances. It can go either this distance or this distance or this distance. It can't go like halfway in there, right? It has to always, because space is quantized, then it can only go integer distances, and as such, it can only fall back integer distances, and it has to fall through each of these layers here, so that what I think is happening is that when the electron eventually hits the atom, is that it wiggles and it sends out a frequency, right? And if it comes in with the higher energy, that means that it's going to wiggle back faster. So let's say we do that. So there's like 2 waves versus, say, 1. All right. I don't have this exactly totally figured out, but that'll give you some motivation for, we see the frequencies being quantized, but I think also the amplitudes of the incoming photons is also going to be fixed. Okay, once again, not the best explanation, but I'm just trying to explain some of the questions that Gary had, like, how is this thing created and why does it do that, right? Okay, but otherwise, once you have your concept of your ray, then pretty much that becomes, Gary's force bit, basically, right? So, I mean, I'm just saying that I've always kind of said this is that, Gary isn't wrong, but it's like this is just one layer but beneath his theory, which is, what in the heck is this force bit, right? Force bit. To me, that is nothing more than magic. If I can spell magic correctly, okay? And I don't like magic. As a physicist, I would prefer to say that everything has a physical explanation that you can explain on a billiard ball. And to address this final point, like I said, when you're dealing with generation of light, the quantization of space, it can only move in so many places, is very important. But now he brings up the question of, well, you can't ever have, a line like that going through there. And I would say that is just a question of fineness. Now, I would think that the ether is much finer than comparison to the size of, say, your light ray, right? So whether something can go like this depends on like how big is your light wave in comparison to the medium that's carrying it. So you could argue the same thing for the screen on your computer, in that, well, how are you going to draw a line like this through your computer? You're going to get, the best you could do is, like this. You see jaggies. And it's like, yeah, that's true. But if your screen is very, 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 very much finer, like it is on our screens, then yeah, when you look at it, it's going to be able to follow that path. So that is how I reply to that point. Okay, so that's enough for that screen. So let's go on